Good morning, students. Once again, I am here in front of you to bring another video of third exercise of the chapter Exponents and Powers, in which we shall deal with scientific notations, that is, expressing large numbers in the standard form. Now, children, in the very first video, I had explained you that we often come across very big numbers like the mass of the planet Earth, which is 5970 followed by 21 zeros. Now, such a big figure is very tough to speak and to write. So, standard form allows us to deal with such bigger numbers in an easier way, and that is how we can write it as 5.97 into 10 to the power 24 kgs. Scientific notation should be used whenever a situation calls for the use of very large or very small numbers, such as distance in space or the size of atomic particles, dealing in science, as scientific calculations where the analysis must be very precise and accurate in their calculations. Now, children, in UK and countries which follow British conventions, scientific form is another name for scientific notation in the UK. Scientific notation is one way of writing very large or very small numbers using the numbers between 1 and 10 multiplied by the power of 10. For example, the numbers greater than 10 use a positive power of 10, whereas the numbers less than 1 use the negative power of 10. Check the example, as a number 6350 can be written as 6.35 into 10 to the power 3, whereas a number in decimals, that is 0.0246, can be written as 2.46 into 10 to the power minus 2. Now we shall study about the rules for applying a positive or a negative power. Now, students, in India, we follow scientific notation for writing very large or very small numbers with the power of 10, whereas standard form is the normal or regular way to write a number. Now, while writing a number in standard notations, we write it as a into 10 to the power b, where a is the number whose value is greater than or equal to 1 but less than 10, means it should be a one-digit number, multiplied by a base of 10 and an integer which is a power, means as many times the base is repeated. Now, to convert a number in its standard form, the first step will be to move the decimal point until there is one digit to the left or it is remaining to a single decimal point. Now, exponent goes up as the decimal point moves left, whereas the decimal point moves to the right and exponent goes down. The following examples make it clear. Now, children, to deal with numbers which don't have a decimal, we shift the decimal towards the left, as if in this number 1,56,000 we have 3 zeros and 3 numbers. So that is how decimal at the last shifts to 5 places towards the left, and so it gains the power of 5, and we have 156 or 1,56,000 converted into 1.56 into 10 to the power 5. Now check this number, which is a decimal number where the whole number is 0. So that is how we have the number here 0000053. Okay, numeral part is just 53 and we have to bring it to the value of 5.3 into 10 to the power minus 6. Now, as the decimal is shifted from the very first zero of the decimal part to 6 points on the right, and so it gains the power of minus 6, and so ultimately this number is converted to 5.3, where 5 holds the first position, which should be less than 10 or a single digit number, and 3 holds the numeral part into 10 to the power 6. Now, after going through the examples, we can summarize the rules here as if first point, move the decimal point so that the number is greater than 1 but less than 10. Remove any of the insignificant zeros. Count the number of decimal places in which the decimal point has moved from the original number, and this will be the exponent or the power of 10. Now, if the original number was a smaller number, then the exponent is negative, whereas if the original number was a bigger number, then the exponent will hold a positive power. I hope I am clear with the explanation. Thanks for watching.